Hi, everyone. Welcome to the Infrastructure Network. This is the Infrastructure Live Roundtable that we're having to discuss CIPP safety and quality. I want to welcome all the guests, Ken Carlson, Chuck Hansen, Mike Kenny, for joining me. We have another guest joining us hopefully here soon. That's a scientist that will give us some insight, as well as thank you to the audience. Comments, throw some comments out there as we get this conversation going. We love listening to your questions and your concerns. Also, want to thank all the construction workers out there every day fixing infrastructure. It is a tough job. It's not easy getting in the trenches and digging and lining pipe. It's a process. I want to say thanks to you guys for really doing the work that needs to happen to fix infrastructure. I want to go through a quick introduction as far as the timeline of how this event started. On Friday, I posted a video just explaining my frustrations after this article was posted about curtain-place lining. Since then, things have changed. I spoke to a nonprofit organization, and they wanted to do a live event. So, and we talked on the phone. We were going to get scientists involved, and it's been a whole thing. Since then, I've met with them on Monday. We talked about these concerns they had with the title, description of the event, and ultimately decided that they didn't want to be a part of that. So without using names, but this is their statement. They feel that the proposal to commingle quality control with styrene safety in the roundtable will not provide the focus either topic deserves. Now, I want to tell you all that I invited both sides of that US Today article, both sides, to bring to this table to talk about the problems. Neither side showed up. And I'm not trying to, cause any kind of issues, but it's important to understand that we're trying to solve problems, real problems in infrastructure, especially when it comes to putting in quality, long life cycle of infrastructure and make sure it lasts 50 to 100 years, not 2 to 5 years based on workmanship, quality, accountability, things like that we're going to talk about. Now, that being said, I put a panel together. And my goal was to put a panel together that had a scientific study, a background, someone that could talk scientifically about the chemical, someone that can talk about operation and maintenance of pre-cleaning, post-cleaning sewer pipes, also someone that's involved with inspection and understanding post-CIPP, what the conditions of the pipes look like, as well as Mike Kenny, for example. I didn't announce names, but now I am. Mike Kenny, as far as an engineering side of this, who builds and designs specs for CIPP all the time. The only two people that didn't show up for this is an installer and a scientific person, but we did have a Ned, and I can't pronounce his last name. He might show up randomly in this conversation. So you might see somebody else pop in. So needless to say, Kent Carlson, can you give us an introduction and your experience in the industry?
Oh yeah, thank you very much, Chad, for inviting me. Yeah, my name is Ken Carlson. I have over, we were just talking about that earlier, but over 40 years time in wastewater collections, treatment, as well as conveyance. I worked for the city of Los Angeles as an operations manager for over 30 years and retired, and now I'm the vice president of the National Clay Pipe Institute. The majority of my work is education in regards to construction, maintenance, operations, as well as assisting cities with training and design work. So, through this time, I've come in contact and worked, with CIPP in regards to, using it for repair. And so, my experience comes from actually, post installation cleaning and maintenance and making sure it operates correctly. And also too is different type of liners like spiral wound and sectional. So anyway, that's just a little bit on my background.
Thanks, Kent. I appreciate that, Kent. Chuck, you're up next.
Hey, thanks, Chad. Yeah, I'm Chuck Hansen with ElectroScan, formerly Hansen Information Technologies and Hansen Software. Like Kent, I go back about 40 years, back in the early 80s. My first time, I think CIPP was my career builder. Back with the City of Houston project in 1989, when Hansen was the standard for CCTV inspection, not the British version. We had over 220 TV rigs assessing the sewers of Houston And we actually built the very first programs that automatically use CCTV to recommend CIPP lining, complete replacement, slip lining, and so on. So it was a long time, and that was back when most of the CIPP was installed by licensees. And so I owed my experience to the great folks out of Pasadena, Texas, at In Situform Gulf South, Will Naylor, Jim Witt, that basically taught me the lining business. And even at that time, I remember standing in the steam, the harmless steam, when it had no problems to it. Maybe that's what got my hair in such great shape. But fast forward to 2017, my guys were out doing scanning, since CCTV is not the way to assess or accept CIPP. And I get a phone call, and one of my guys is lightheaded. He's being overcome by the steam. And this is 2017 with a local client. I won't identify him or the manufacturer, but quite a large company. And in finding out, it was standing inside of a plume that when I saw pictures of it, I couldn't even see his face. So this is a very current. When we have workers out there, we lost days of work because I pulled the crew out. They all felt sick. And so, when we looked at this, because we do inspections right after curing, now we do not allow our crews to go out unless we have full compliance and understand kind of the things that are going on. So a very current topic for anybody working around this technology.
Appreciate that, Chuck. Mike Kenny, you're up.
Thanks, Chad. My name is Mike Kenny. I'm a project manager with Baxter and Woodman here. We're an engineering consultant in the Chicagoland area. Been working in the engineering realm for a little over 10 years. My main focus has been on sanitary sewer rehabilitation. So a large part of that is CIPP work and recommending improvements to a system. That's mainly to remove I&I or to repair, structural defects within a sewer that's cost effective. Digging up, miles of sanitary sewer would be a lot more expensive than lining. So it is something that we are often recommending. And, I typically, I feel like at least once a day, I'm talking either internally or with a client about CIPP, not only for gravity sewers, but pressure pipes as well, force mains, and more recently, water main is becoming another item that's really picking up steam here. No pun intended for using lining for.
Appreciate that, Mike. And as everybody knows, I've been doing live events, these social events, podcasts, things like that, to bring engagement and awareness to infrastructure. I look at this as a platform to just bring light to these concerns and talk about them. So I've been in the industry 20 years. I started in wastewater when I was 15, cleaning wastewater tanks. I wanted to get out of sewers. I came back in, I think it was 2010, something like that. So I've been in the industry selling services, involved in rehabilitation, building specs, things like that on the manhole side, and helping engineers put together specs on the horizontal pipe lining side too. So it's a lot of experience here on this event. We might not have the scientific people to sit there and talk about the chemistry within these resins and epoxies that are being used in rehabilitation, but we do have a lot of experience here. So I think in order to keep this organized, we're going to start by educating people with Mike Kenny's experience on when a pipe, let's say a pipe's in the ground, it's cracked, it's got issues, it's been a failure, rates high. You have to make a decision, Mike Kenny, and what's that going to be? It's going to be how to fix that pipe, right?
Yep.
So go through that process.
Sure. So, typically what happens, we get one or two calls from clients as we start looking at the systems. Either they're having a lot of I&I issues, inflow and infiltration, clear water into their sanitary system, or, they've had a collapse in their sanitary sewer, or they're experiencing backups, or a combination of all of that. So we come in and we start taking a look at their system as a whole and prioritizing, their sub basins that we want to look into first. And really the first step of even implementing CIPP is we do look at the cleaning and televising videos that, contractors go in and clean the pipe. We get actual video of the sanitary sewer itself and, through some training and accreditation to keep the recommendations standardized, we go through and code the condition of the pipe. As I alluded to in my introduction, digging up open cut, replacing sewers is expensive and sometimes is really not feasible depending on where the location is. For instance, if I'm in the Chicagoland, if you have a sanitary sewer that's going under 294, the big expressway over here, can't really open cut that, and
Right.
jack and boring is pretty expensive. So we take a look at what's practical to line. It's non-intrusive, it's a trenchless method. So after we take a look through all the videos for a certain segment, we prioritize, which sewers are in need of rehab. And there's a determination we make if lining can be accomplished. Sometimes lining can't be done because there is a collapse in a pipe, or, there's an offset joint that is too large where, the liner may not make its way through. So we go through and recommend locations for point repairs prior to lining. And then some in rare cases too, we recommend that, lining isn't practical because the pipe is in such rough shape that it really just needs to be replaced because the liner is not going to, really do its job, or it's going to have a bunch of lumps in it. And that's really just due to the condition of the pipe. That's really the baseline of what we're looking at and how we're making our recommendations.
Thank you, Mike, for clearing that up. And I'm coming back to you. We have Dr. Ned Ranpara. Thank you for joining us. And we didn't get your introduction. Could you do your introduction, please? Thanks.
Sure. First of all, my apologies because of the weather issues. We lost the internet, and I just realized that how much we have been depending on the internet these days for any meetings. Standing in front of it. So my apologies to begin with. So I'm an MD from India, came here and did my master's in public health and industrial hygiene from WVU, West Virginia University. And then I worked at CDC NIOSH for about 9.5 years, and during which we had to go for multiple health hazard evaluation program. So I'm sure that the attendant of today's meeting are kind of aware about health hazard evaluation program, but if not, then we can go about discussing about it later on. But that was the program. Out of many, I got involved in CIPP, and initially we had the request from the employer or workers, and we had to go there and do the safety analysis. Now we have NIOSH. We don't have the legislative control, or we are not OSHA, so we can't turn anybody down, but we can investigate regarding the safety and provide them the recommendations for whatever we are reading, and that's exactly the purpose of this meeting. And I was fortunate to actually go in the field and collect the samplings and do the sample analysis at 3 different occasions for the CIPP, and that's where I'm serving in this meeting for providing the scientific impacts. In the sense, now I'm not working as NIOSH because I've been working in WVU as a research scientist, but part of my job previously was at CDC NIOSH, which is exactly the next door from where my research facility is. That's kind of questions that I would like to receive and happy to provide input. Thank you.
I have some questions for you. Obviously, once we're going to go through the process of learning more about the process of building a project at CIPP. I think that's very valuable for the audience, I hope. And then that'll give us some clarity on what's potentially going on and go from there. So, Mike, going back to you and talking about once you figure out, let's say it's a CIPP project, right? You already determined that this is a CIPP project. What are the next steps that need to occur to install a liner, for example?
Sure. So we take a look at, the existing conditions and where the manholes are located. After we determine, hey, this segment needs to be lined. As part of that work, we do take a look at the businesses and schools and other like institutional, buildings that are in the area, because we just have to be aware of, the services that are connected into that main line. So something we do like to take a look at is, how much flow is coming into that sewer. Lining does take time to cure the pipe. So, if you have a really active user that has a service, and then depending on elevations, you could have a customer that, if they're using, if they're constantly, if it's a school, for instance, if they're constantly flushing their toilet, like we want to give them a heads up, like, hey, we're going to be out here lining this segment. It's kind of hard to tell a bunch of kids and, reduce the bathroom use, but, your service is going to be kind of blocked off until you can get it back open. So we want to take a look at like the overall picture of what we're doing. But once we make those determinations and coordinate with our client, we put together, a specifications manual, which keeps the standards of what we're looking for the installer to do pretty tight. There's plenty of, qualified installers for the work, and we want to make sure that it stays that way. I know there's new companies that pop up all the time, but we just want to make sure that they're following the standard, the standards for installation, and making sure they're doing quality work, and at the same time that they are being safe. Because, not only are we concerned about the safety of, the contractors doing the work, but we want to make sure that, they're being safe with, residents, because a lot of this work happens, right along the parkway in residential neighborhoods. So our specifications, we put those together to make sure that, proper traffic control and proper safety barriers are put in place. If, let's say it's a larger diameter sewer and they have to actually excavate out and pull the cone off the manhole to get the liner in, we want to make sure that, no one's falling in, and that the contractor's following all the appropriate safety standards.
Okay, thank you. That's very helpful. So there is a preparation period to put a liner in that it needs to occur, correct?
Yes.
What is the method for cleaning out a hose pipe that's already that's going to receive the liner?
Sure. So typically, we call it here at my office the pre-cleaning televising video. So the contractor goes in. Typically, the pipe has already been cleaned probably within a year or so, and that's how we identify the need to be lined. The contractor will go in, they clean the pipe to make sure that, there is no large intrusions. There's not root balls that grow in between the joints that aren't going to allow for the liner to be installed successfully. So they go in and make sure that the pipe is clear, and they have different ways of, cleaning that pipe with root cutters. And, if there's a intruding tap, they can, cut that out and make the pipe as smooth and as clean as possible. And we actually review those videos before they go ahead and install the liner, just to verify that the pipe is still in good condition for the lining. Because believe it or not, you wouldn't think a sanitary sewer condition would change rapidly, but I even had on my last project, over the course of 9 months, we've had a section of pipe that was lineable turn from, it's cracked and fractured, but it can be lined, to all of a sudden they do the pre-cleaning videos and, oh, wow, this pipe needs to be actually replaced before they can line. So we always just want to make sure that we're taking a look, right before it's getting lined. It doesn't happen often where you have to make a change like that, at least in my experience, but it's just something to look out for. And then with those pre-cleaning videos too, we want to identify all the sewer laterals that are coming in. So the sewer services from homes, buildings, and we take an account of those from the engineering side. So as soon as they're done lining and they open those services up, we can essentially count and locate all of them to make sure that everyone has sewers flowing again.
Okay, great. So that's a great explanation of like how we look at pre-cleaning and preparation of a liner getting installed. Now, Kent Carlson, you've made claims of there's an issue there with the cleaning of preparation of these CIPP pipes, or not just CIPP, or sorry, not different types of pipes, but in the preparation phase, I guess, of cleaning a pipe. And what is your studies, or what have you found that is causing maybe this issue of preparation prior to a CIPP liner being installed?
Well, thanks. Our flow chart on pretty much deciding whether or not we were going to use some sort of, other than open cut and replace the original pipe, was similar to like what Mike did, but ours was determined internally with the city of Los Angeles with cooperation between operations and also with the engineering department. Now, the thing is that when I came over to wastewater collections, there had been different types of CIPP and different types of liners installed in the sewers when I came on over to start working on the cleaning side of the house. I know the first one was F1743 ASTM, and that one came out in 1996. And that was the first ASTM standard that really came out that talked about the installation of CIPP. Before I really started getting into addressing and analyzing, standards for pre-cleaning and standard operating procedures for making the decisions on what to use as a repair, I started noticing that a lot of crews were coming back into the yards and notifying me that they inadvertently tore up a bunch of CIPP or liner. Spiral wound liner was notorious for getting hung up on our cleaning tools and our high pressure systems, and we were pulling out miles of this stuff. It was fascinating how the product itself would not withstand our cleaning processes. So at the time, City of Los Angeles was under consent decree with the EPA, and we had to, by law, implement a very aggressive cleaning process. So we probably had one of the most aggressive cleaning standards in the whole United States. We were using, 2,500 psi at high GPMs. It's like 2,500 psi at 125 to 200 GPM. We were using chain flails and mechanical cutters, hydraulic root saws on every pass, and we were also cleaning at 95% of operational capacity. We also had bucket machines, mechanical rodders, so we threw everything short of explosives at our pipe to keep them clean. Now, our goal was to reach 95% of operational capacity. So when a crew walked away from that pipe, that's what it was clean to. So during that process of this aggressive cleaning, we were tearing up everything that was inside of the pipe, and that was the goal. We wanted to clean out the grease and the roots and the debris and everything else. But, when you send a cleaning instrument down the side of the pipe, it's almost like a Scud missile. It has no bearing on what's in it. It just gets that product out of there. I witnessed some CIPP lining when the tool was coming back. It looked like sauerkraut being blasted down the downstream manhole because it just could not handle that PSI. So part of the process too is really starting to take a look at what type of repair methods we were going to use based on our cleaning schedules and SOPs. And it was interesting. I was looking at two different standards. Well, actually, for the city of Los Angeles, I had three bosses. I had the federal government, EPA, Cal OSHA, and also too as NIOSH. Thank you, doctor. And we had the state of California, we had the city of Los Angeles, and those were the three entities that had to work with it. So the big one was the EPA and my cleaning standards. So when I started looking at how our tools behaved down inside the pipe, I started researching two different standards. I did ASTM, which was the go-to standard for engineering from the federal government, EPA, as well as standards for construction. And I also started looking at the what the manufacturer recommended. And I was pretty much shocked that when I would call around to the different manufacturers or of CIPP, that there really wasn't a standard on cleaning. They didn't really have it much of anything. The only one that I came across was one that was by Aegon and Instituform that said you have to clean at 1500 psi. You couldn't use any mechanical cleaning equipment like drag scrapers, chain knockers, root saws, bucket machines, and porcupines. And it says CIPP should never be mechanically cleaned. Well, that cut out 60% of the way
Hold on a second. You just said CIPP cannot be cleaned.
It says cannot be cleaned mechanically.
That's in a document?
Right here. It says Aegon and Instituform. This is a cleaning process that I was given for the cleaning process of cleaning CIPP right here. Aegon and Instituform.
Interesting.
And that's the only one that I could find. Right.
Well,
So
I don't want to go too deep into this yet because there's a method of like us figuring out the process here.
Yeah.
And I want to just understand that, the cleaning process is essential to going in, jetting out, and then putting in the liner.
Yeah.
Is there any issues that you could have seen with, the cleaning methods that would prevent a CIPP liner from going into the pipe?
Sure, you follow the recommendations of the manufacturer of the product. That's what you do. Okay, so when I found this out here, that unfortunately we were going far above what the recommendation cleaning methods were, we had to start marking the manholes where this product was installed. So if you rolled up, you looked down inside, there was spray paint right inside the structure, then you knew that there was some sort of a liner or repair. Then you would throttle down your cleaning process and not use mechanical cleaning methods. It was tough because we didn't assign pipes by different type. You're going to take this bucket machine out here. So we had to backtrack and figure out how we could work around these products and not mess them up. So that's why we're reaching out to the manufacturer, because no one really knew at that time, right? So finding out what the standards were very important to me, because I just didn't want to start tearing up tens of thousands of dollars worth of install. So we had to start marking out where these structures were that were lined, and then adjusting our cleaning process accordingly. So that's where I was. So that's where I started finding out about how CIPP withstood our cleaning methods, right? It was accidentally, and then basically, luckily, that I got this document that said this is how you do it. So I assumed that was my only baseline. Now, when I started looking at ASTM standards, for example, F1216, which is the rehab of pipelines with resin impregnated tube, it says in there that 40% obstruction is allowed prior to the installation of the product. But since we had 95% operational capacity cleaning, I couldn't allow 40%, and that's in the ASTM.
Hold on. You're saying 40% of the pipe could be blocked by some material, and then they could line over it?
It says in the standard, it says that no more than 40% of obstruction can be allowed prior to installing the product.
So Mike, Kenny, look, if I'm hydraulic modeling this thing and you start putting in liners that are 40% capacity, you reduce the capacity, you got 60%. Isn't that going to provide a problem for hydraulics?
Yeah, especially if you're looking in areas where you have, existing issues. I have actually run across, exactly what Ken is talking about with, we're installing a liner. I haven't done anything quite as large as 40%, but I would say, 15 or 20%. And that's a conversation we have with our clients and the communities. And we take a look and say, hey, we're going to be, even if you're reducing a 1 foot segment, by 20%, you're still putting a choke point in that whole entire line. Yeah. So it's important that we talk with our clients and say, hey, you have a couple options here. We can line through this obstruction, but you're going to have a reduction in capacity, or we could go ahead and dig this thing up and replace it. And the couple times I can think about where we lined it, it was just in a really tough spot, and the client didn't have any concerns about their hydraulic capacity. And I think in both cases, the pipes were oversized to begin with.
Okay. So very helpful. Hold on, Kent, just on time because of restrictions, but go ahead, with whatever you're going to say there.
I'll just wrap it up. We just found that there's inconsistencies in the ASTMs. For example, F2516, which has 20% obstruction. F1216, like I said, 40. F1743, 40%. F2019, which is rehab plat plans with GRP, CIPP, is they'd say clear of obstructions, and 2599 is 20. See, so there was an inconsistency. And so different, yeah.
What's the dates on these specs? Are they still being used?
Oh yeah, they're all still being used. The latest one was let's see, it would be F2599 by the number. Oh no, excuse me, F3097, which is 2015. You know, and so that's where it was. So they're all current. They're all current.
Perfect. Okay, so
Yeah.
so you're saying all the ASTM standards are current. This is the current model. Now, Mike, Kenny, is this what you use to basically write specs off of?
Yeah, we do follow the ASTM standards that Ken had mentioned. You know, we're always looking, if anything gets updated, we're always updating our specs to reflect that, and just, you know, what's the industry standard. And,
Okay.
you know, the big thing is we're always evolving, you know, with as CIPP evolves and, you know, sewer rehabilitation.
Got it. Okay, so now we set the tone for like how it's installed, how it's cleaned, the pre-cleaning we have to do. All right, so once the CIPP liner, let's say, is installed, now let's talk about the installation process. To the best we can, we don't have an installer, except for from what it sounded like, Chuck, you were in the trenches back in the 80s and 90s. You know, I'm going to go to you because of your knowledge, since I don't have an installer here that wanted to show up. Give me some ideas of how this process works, because I'm still new to it as well. I know enough to be dangerous, but give us an idea of how the installation process works.
Well, you know, just a lot has happened with installations of CIPP, and you know, the methods. I mean, back in the day, you know, we were using boiling water as the key catalyst to thermoset the pipe. It's like anything else. It's like how your mom taught you how to fold socks. You know, we're basically taking a bag and laying it through. We're blowing that bag up, and we somehow have to thermoset that. And so we've got to heat that. So back in the early days, we were just using boiling water, kind of a thermal set to do that. Japan had developed the use of air to thermoset, so steam. That was the old PALTEM method, if you will. So now using hot air to go ahead and thermoset that. Fast forward to 10 years ago, we started seeing UV lights to line that. So and the materials itself had to be a little bit different. You know, if you take a 400-page book, for example, and you take the pages and just rip through the pages, you could see all of these smaller levels. UV not only was a different way of curing the pipe, but it was also a different material of the pipe too, that I'm sure Dr. Youngpart could discuss. And then even the latest has been using LED to heat that pipe. And I think what we've seen over, and the reason why we're here in the USA Today article is each has their own set of emissions. So that when we're cooking the pipe, when we're boiling that pipe, you know, when you look at how boats get made, you know, at fixed locations, and kind of the same process. We build holes, we're curing those. They're regulated by the state, and they actually measure the amount of emissions that are coming out of the airs, whether they're VOCs, this volatile organic compound, or you know, other non-styrene hazardous air pollutants, HAPs, that as they call them. But we really don't have any regulation for that on the lining side. So
hold on one second, Chuck. I want to go just so that everybody knows, like, the wet out process. I want to talk about more of that. I don't want to get too deep into the scientific side of the materials and stuff right now. That'll be another topic probably for another event. But let's do the wet out process. Let's talk about how we put a liner in. Let's go there, and then I want to go to the Dr. Ned about the mixing and the process. That's where I want to go. So
I think Mike actually writes the specifications for that. So
he does.
I think to get a real idea of how it should be done, I kind of look at how the effects of that when it's not done well. Maybe Mike can
Okay,
comment.
I'll come back to you, Chuck. Mike, let's do this.
Yeah, so there are a couple different ways that lining can be accomplished, and typically what I do see, Chuck, talked about a little bit. There's UV cure, there's steam cure. At least in the Chicagoland, I would say 90% of it is with the steam cure. So when let's just say you're a resident and you wake up in the morning and all of a sudden you see these big, large trucks in your block, looking into the manholes. I mean, what you're going to see is a smaller cleaning and televising truck that did the pre-cleaning videos that's out there kind of guiding everything that's going on, the eyes and the ears. You have a larger, I guess I'll call it like a U-Haul type looking truck, just so everyone can picture it. The biggest U-Haul you can get, and that thing is filled with different liners or bags, as a lot of the contractors call them. So when those things come to the site, depending on how they were prepared, it has to be temperature controlled, because if you just leave those liners and there's already resin on them and it's a really hot day in July here in Chicago, those liners are going to be like cooking off in the back of the truck, and they're going to go to pull those things out, and there are going to be even sections that are like hard as a rock. So there's a lot that goes into the prep of the contractor even bringing those liners out to the site. There's different ways it can be done. There are like wet out facilities which can get the liners. It's essentially squeezing, like pulling this liner through and just soaking it in, the resin it needs to cure as they're pulling it, and then the bags are ready to go. But on site, when they're pulling these liners out of the truck, down into the manhole with a winch kind of pulling them through, they could be wetting them out, out the back of the truck as well. So
Sure.
That's when you see like other trucks involved. So typically, the liner comes out the back of the truck. It's getting prepped. It's getting pulled into the sewer. So once it's inverted into the sewer, that, the truck that had the liner on it pulls out, and then you get a big steam truck that pulls up, and they start actually curing the liner. And then at the other end is where, we see the steam clouds, or however you want to call it, towards the other end with the curing. And then typically it's monitored because you can know what's going on at one end, at the front end and the back end, but you don't really know what's going on in the middle because these liners have to be cured for a certain amount of time depending on the size of the liner, how deep you are. There's a lot of different parameters that go into how long these have to be cured for. So a lot of these liners, as we're getting more technical here, there's sensors that can tell you like how hot it is in the middle of the pipe. And that's something with like UV lining, like exactly where you're at and like what the curing rate is, because you're pulling that UV train down the pipe with you. That's the real basic layout of how lining is installed.
So there's a wet out period, which is where a lot of the chemical mixture process, I've seen this, where they mix it in buckets, right? And they start wetting out the liner. And that's where, all this is coming out about styrene and things like that. And like I said, we're not going to speak to styrene unless Dr. Annette wants to, but what are we dealing with here on these resins and epoxies, Doctor? You're muted, so I got you.
Yeah, exactly. So I wish I have the presentation, and I wish I could share the photos with you, because one picture is
We don't have time for that one.
Exactly. I was an eyewitness because I went to 3 facilities. One is a wet out facility that you are mentioning, and I can share the pictures so you guys would really enjoy. Oh yeah, it's share screen here. Let me share this with you all. Bear with me for a moment.
Sure.
Yeah. You should be able to see it now.
Okay, it's up on the screen. We'll have to make sure this is fast.
All right. Let me know when you guys see it. So okay. So that was a presentation that we delivered, me and my colleagues at NIOSH at Nashville last year. So, but me and my colleague have been there in that wet out facility that you're mentioning. Now, do you see that guy who is standing on the top of this green looking belt here?
Yeah.
Okay, so that is exactly wetting the liner with the material. And that material consists of the chemicals with the styrene predominantly, resin material, and the catalyst. That I think Chad was talking about, the bucket full of liquid stuff that's been in there, that is exactly been poured in. So the green thing is a liquid, and that guy is with his body weight, he's trying to distribute the stuff throughout the liner. And that liner is going to be stored in the refrigerator at super cool temperature. And then those trucks are going to be delivered. The trucks with the refrigerator is going to be delivered to the place of installation. And this, okay, can you guys see the installation?
Yeah.
Let me know when you have, yeah. And that's exactly my friend was talking about, Mike was talking about.
Right. How to wet it out. Mhm.
How to wet it out. It was in the previous picture, but this, sorry.
So these workers are right on top of this. Like they're touching
Yes.
it, they're involved in
Yes.
it, they're wetting this out. Like they're
Yes.
they're making contact with it.
That's
Where is their as far as a safety standard, like what is the safety standard? Like what do we do with this chemical that we're mixing and so on?
So the first thing is to understand is for a trade secret, I could not reveal where we had been and what is the location of the facilities and all the other stuff, and also the composition of that material that's being used for wetting out. So basically, wetting out is a dry liner being injected with a wet chemicals, which is an actual chemical that's being used at the site of installation. So preparation of liner in a facility by wetting the liner with a chemical substance or resin material, it's called wet out facilities.
Yeah.
Okay? Because you're wetting the liner with the chemicals.
Yeah.
And then you go and install those liners at the place of installation using the method that Chuck has mentioned. Either it could be UV, it could be hot water, it could be steam, depend on the site of installation.
So sorry, I didn't mean to cut you off there, but I'm looking at time. So the liner's installed, it's cooking, as Mike described. It's
Right.
getting heated up. Okay. We've inverted the liner, so all the resin is up against the laterals. It's inside that hose pipe, and it's up there, smacked up against there, and it's getting cooked and it's setting. It's creating that fiberglass or that pipe. Where are we having issues with the exposure then that people are talking about? Let's talk about that.
So to answer your question directly, you are talking about the exposure at the site of installation, not at the
when it's cooking.
Yeah, when it's cooking, yes. So now let me share with you another picture where you can see the site of installation, which will align with how Mike was talking about. Okay, there we go. Can you guys see it?
Yep.
Okay, so the first picture is exactly when you are taking the liner out from the truck, that you can see it, and then put the stuff through a roller, and then you install the stuff in, and then the heat is going to start. So immediately after you open the door of the truck like a sash, and you have a burst of styrene powder being out. The reason is it's been stored at super cool temperature in this refrigerated truck, and now you are exposing it to the atmospheric temperature.
Heat,
and, atmospheric conditions, even before you put the heat in that one. So that's a super cool condition, because otherwise this resin material is going to get solidified by room temp, or even the heat, or it's going to get wasted. It's not going to maintain the integrity of the liner. Then it will have all the heating stuff. And now in the second picture, if you are seeing it, is once it's been hardened by the heating stuff, whatever, water or steam or UV, whatever, then this guy is going to cut. Look at that. There is no gloves or none of the way that he can, and as long as he's going to keep on drilling this to provide the determined length of the tubing or liner, there is so much of styrene being emitted, because the same styrene has been used at wet out facility to build up that stuff, which is right here. So if you see the liner preparation, so basically you are cooking out what you are putting in as an ingredient in the cookie, right? So the wetting chemical contains styrene, and when
Now, sorry,
go ahead.
doctor. So we get that part. What's this vent stack? Let's talk about the vent stack. I've heard of this vent stack. I've heard about how it goes up when it's cooking, it goes up the lateral. Obviously, there's issues where it can go into homes. Let's talk more specifically on that quickly, if you could.
Sure. So there are two aspects. So these pictures I have shown you guys to see what's happening, which is immediate exposure to workers, which is what NIOSH was interested. But we are also interested in the public health safety, that what's happening to the people around. So of course, they would have given a notice when they are coming in and fixing over, probably.
So they get a notice, the residents and commercial property, everyone gets a notification. Okay.
But if they have it somewhat more in prior, like few many days back or so residents or people surrounding, like Mike was talking about in the school facility or facilities where a larger number of people can be affected, even at the time of installation, because you will have so much of styrene. So powdered styrene is gonna be the main source of exposure. I'm intentionally using the word styrene, which is the main chemical.
You are, that's for sure.
Yes, and there are so there are other chemicals, but styrene is predominantly the majority of the exposure, majority of the chemical that's present in the exposure. Okay. That could be acetone, that could be other stuff, but styrene is like super high.
So it's pretty nasty stuff. Is what we're talking about here. So, okay, and I've smelled it before. It's not pleasant at all. It's not something you want to stay around and hang out with. Okay, so moving forward, I just want to kind of keep this process going because we're running out of time. We're cooking this thing. It creates a liner. It's a new pipe. It's inside there. There's obviously potential for exposure risk when it's cooking, worker safety, things like that have been brought up in the media, obviously, with these articles. Chuck, you've been time wise here, we probably got about 5 minutes for your topic there, Chuck, but talk about like after it's cooked and installed, what you've been seeing over the years of inspection of CIPP pipe, because you've been an advocate about it sometimes not working.
Well, and I've been a reluctant advocate because it wasn't until 2010 I got a call from Ken Carey. And Ken Carey, a lot of folks know, wrote the book for the EPA on CMOM and applications. And Ken calls me up and he says, look, some of my old students are having problems with their CIPP pipes. They're collapsing. And I said, well, is that 20 years, 30 years? He says, no, it's 2 years after the installation. Do you know anything that can assess CIPP? I go, well, what's the camera show? And he just shook his head. He says, cameras can't assess CIPP. He says, got to have something else. So he and I actually did a world kind of search for technologies. And we found this technology, this electroscan thing, that basically could use low voltage electrical current and examine 360 degrees of the pipe for permeability. If electricity goes through CIPP, there's a hole. And if it doesn't, that means it's good. So the big study that was done, engineering firm in the Midwest, in Racine, basically wanted to quantify the reduction in infiltration. I&I, we know, is a big issue. We know CCTV cameras don't quantify II. You've got to look into the joint. There's some joint call outs, but from an IA standpoint, we want to quantify kind of the before, what was the infiltration, how many gallons per minute did we have in this area, and after. So we looked at doing this. We did scanning before on a 6,000 foot area, about 28 pipes. And we came up with a quantification of infiltration coming in at every joint, every bed connection for the pipe. The next day, all pipes in this area were lined. Fortunately, 2 years before, there was a flow meter that was placed because we wanted to calibrate it with flow meters. So we want to measure the reduction in flow from lining. And we all know kind of claims that are made. Yeah, we eliminate infiltration. Yeah, that's good. So that was done. the day after CIPP was completed, we went back and rescanned, and we calculated a 70% reduction in infiltration. The key thing is we needed to wait 2 years until we had another storm event so that the flow meters could actually have that delta. What was it before and what was it after? And guess what? It was identical. We had to wait 2 years for the flow meter, but it also registered a 70% reduction. Now, the thing that really shocked the industry, and that's why people are changing their acceptance of TV to technologies like ElectroScan, is that of the 28 pipes, not all of the pipes had a 70% reduction. Some had 100% reduction. Some had a 70% reduction. Some just had a 20% reduction, and 20% of the pipes actually leaked more after CIPP than before. How is they all netted out 70%, but now we had verifiable proof of this number of which pipes were good and which ones weren't.
Yeah.
The client was beside himself. The engineer scratches. How could that possibly be? It could worse. So we went in and we used TV to take a look at it. One thing that hasn't been discussed so far, and really a big problem, is the cutouts. You know, the reason that you do a visual interpretation of the pipe is you want to know where the dimple is, where you're going to be cutting precisely where that was. And those pipes that were actually now linking more. So yes, CIPP had solved the joint issues. And again, this technology was used by IKT on their last CIPP project with some very interesting, and they actually helped us refine defining what a pinhole is. But we actually could see where the cutouts were so much worse. And so we had just shifted in that particular pipe all of the benefit, all of the gain from the joint now to these poke and hopes that we have. So, you know, in looking at the quality of the pipe, it really comes down to the installer, and it comes out to how well they're going to be. Some of the dimples are obvious. I mean, even I could do it. But, you know, what could possibly go wrong with a 6-inch rotating blade in a pipe that you've just relined? You know, come on.
That's not going to be good.
And the problem that we have here, unfortunately, is the specifications, and still the majority are let's TV it. And of course, the contractors really will only use TV contractors that come back with 100%.
This is Chuck. Okay, so this has been one of those things where I'm trying to figure out where the installing issue is. Obviously, we don't have an installer specifically that's been doing it recently here. Mike, have you seen or heard of like issues with liners being installed incorrectly and that kind of stuff?
I mean, I have seen a couple liners where, you know, we go back in a couple of years, you know, the client, you know, these specific ones where, you know, they're chasing I&I issues all over their system. So they actually went in, you know, and re-televised, or they had, you know, a restriction in their system. And I have seen in 2 occasions where like a section of a liner actually did collapse in on itself. And usually that can be attributed to, you have a section with so much I&I going on, and you have, you know, water pouring through a joint. It can wash away the resin as a liner is curing. So you're going to have a soft spot.
Can you repeat that one more time?
Sure. So if you get an installer who goes in and they put the liner in, and there's a lot of I&I coming through. So through a joint, you know, if I'm going through and coating something, it could be, we label them as like infiltration runners or gushers. You could have water pouring into a section. And if that's not noted in the pre-televising video and that liner's installed, the resin itself can get like washed away from that section where the groundwater is pouring into the pipe.
Wow.
So you can actually have like a section of the pipe collapse because there's really nothing holding that together. You know, that is at least in my experience, that's a rare occasion. And
Yeah.
typically if we see that I&I, we will grout the joints or something beforehand and then line, because then that issue is hopefully non-existent after grouting.
Well, yeah, I appreciate that, and thanks for the explanation.
Well, and that's called, so again, that liner will cool. And just like George, there's shrinkage. So because the liner is not adhesive to the hose pipe, and I've got this annular space that is going to be at the crown. If my TV hasn't, and we only televise the pipe when it's dry. If we have active infiltration, we get lucky and see those things. But that's why if CCTV is missing 80% of where the sources are, you're going to be at risk at that. So with that water kind of flowing through, not knowing where to grout, which is a great tool, you're going to be having water pouring in through that annular space, and that water is just going to gush down. So of the 3,000 CIPP assessment projects that we have done, that is classic. And again, we were doing a project in Ohio, and the pock marks in the liner were so bad. And I go, I can't believe this TV was turned in. He says, well, the TV usually gets done the next day because the pipe will never look that good again. The TV in this case was delayed a month, and it was during the wet season. So you could just see these infiltration stains and these pox marks throughout this 100,000 foot CIPP liner. And that lining company was never used again in that project. So assessing these things, is really an important factor. That
it really sounds like, Chuck, that we have an installer issue. I mean, that's really what it comes down to. It sounds like, and I'm not trying to talk bad. There's professional installers that do a great job in this space, and we got 4 minutes, so I'm going to talk. After everything we talked about, there's been 100 million miles or feet of this stuff that's been in the ground, and structurally, it's been great to fix pipe that's ready to fail. It makes a lot of sense. There's nothing that's more economical or sustainable than putting in a liner to fix a structural failing pipe. It makes sense. To stop I&I, to say it stops roots, to say it stops grease or whatever, it's not going to do that. It's not. And then, if we're looking at the safety standpoint, we need to make sure that the installers know what they're doing. Like, how do we vet that? Like, how do we actually bring accountability to this, process? It sounds like we had a safety issue with people getting hurt or whatever. And then we have an installation issue. So I think, being time-wise, I cut these off in an hour. We're going to do another episode, and we're going to talk more in depth. And I invite David Kuzman. I've seen some of your comments, and I apologize to everybody. I can't get these questions and answers right now. We're going to address them afterwards. I'll do it. But I invite you to join us on the next event. I think now that, I'm not going to mention names, but the nonprofit that didn't show up, it sounds like, I get it. They're doing great things. They've done great things for the industry of providing standardization. Now the issue is quality. It really is what we just described here is a potential quality issue. So the good installers are getting outbid by not so good installers, maybe. Let's talk about where this process is beginning to really analyze where we can make a difference and become more safer. I really want to talk about our engineers overseeing these projects while they're happening, but we don't have time for that. That'll be the next conversation. But that would be important to know. Are these engineers like on site helping oversee the projects? Because I've seen some situations where the engineers don't show up to the construction site for weeks, months, and they're never there. So you're kind of just letting this fester with quality control issues. Anyway, thank you all for joining me on the show. It's been great. We're going to announce another episode about CIPP. We're going to invite anyone that wants to come and join us to discuss these issues. Sorry we couldn't get to everything today, and we'll get to the scientific side of the resins and exposure, which I can't articulate too, but we'll find the experts to do that. Thank you all for joining me.
Thank you, Chad.
You guys have a great day.
Thanks.
Happy Easter.
You too.